All right, gang. We're gonna take a look today at geometry. So as we're kind of narrowing in on our test tomorrow, I want to make sure that we have a firm grasp, particularly of our triangles and quadrilaterals. I'm going to encourage you to look at all of the notes in your binders, look at all the exit slips, but really drill in on understanding what a triangle and a quadrilateral is. So we're going to get started. I'm going to kind of, for lack of a better word, fly through last week's instruction just to kind of get you prepped for an activity you're going to do in just a second. So the first thing we're going to look at is, let's take a swing it over here. The second learning target, which we actually did this last Tuesday, is I can classify triangles by their sides and angles. The key to triangles is really understanding how to look at the sides and the angles and to kind of piece together what are the defining attributes of each type of triangle. So we're going to look at each type by the side and by the angles, just kind of a review of what we did. But before we start, let's talk about what a triangle is. The geometric definition for a triangle: it is a polygon with three sides and three angles, and all angles add up to equal 180 degrees. I think this is just such an important part of understanding the triangle, is that all of the interior angles must add up to equal 180 degrees. So I'll be honest with you, you're not going to see that on a test, but like foundationally, like as we move forward, that is just a huge part of understanding the triangle, because particularly like with the equilateral triangle, which we'll talk about in just a second, it's that you know that the only degrees it can be if all angles are equal, and 180 divided by 3 equals 60, that is a defining attribute of the equilateral triangle. So it allows you to take a broad description such as all angles are equal, and you can really narrow that in and say, well, on an equilateral triangle, all angles equal 60 degrees. And there's several other ways to apply that, but I think that's an important part. So let's jump in as looking at classifying by sides. We're going to start with that equilateral triangle. Now, I want to be real clear here, is that with an equilateral triangle, all sides are equal, but consequently, if all sides are equal, so are all the angles. So what we know about this equilateral is that yes, all sides are equal. This is really just a blanket statement that really kind of captures the essence of this shape, but it also, and we use our congruency marks here, we know that this, and this are all equal, and then I also know that this is 60 degrees, 60 degrees, and 60 degrees. So with the equilateral triangle, it's kind of that perfect triangle that you probably learned about in kindergarten, just that first shape that you ever shown. But this is the equilateral. From a sides perspective, it has three equal sides. Also, consequently, that means it has three equal angles, which we just talked about. The second type of triangle, if we're classifying by sides, is the isosceles triangle. And an isosceles triangle, what we see here are that we have two sides that are equal. So in this particular triangle here, I notice that the base is considerably shorter than these two sides, and those two sides are of equal length. Again, consequently, because we have two sides that are equal, we would also see that these two angles right here are also equal, because with two equal sides it will result in also having two equal angles. This is the isosceles triangle. The third type of triangle, when we look at classifying by sides, is that the scalene triangle, and it has no sides that are equal, and then consequently all of the angles are actually different. So this triangle here has nothing that is congruent. Remember, congruent is a term that means equal or the same. There's no two angles that are the same, and there are no two sides that are the same. So this is the scalene triangle. So just a quick review: when we look at the sides, we see the equilateral. It has all three sides are equal. We see the isosceles, that means that two sides are equal. And then we see the scalene triangle, which has nothing the same. It is just a jack of all trades when it comes to the triangle. So these are just a quick overview of classifying triangles by sides. Then we begin to look at, well, let's classify them by angles. And then we'll start to see, well, this looks a lot like one we've just talked about. And that's really the point, is that we can kind of pair some of these together. So let's take a look at this. This is the acute triangle. Now, in an acute triangle, we have to see that all of the angles are less than 90 degrees. Now, they don't have to be equal, and some will be equal and some may not be. For example, in an equilateral triangle, they're all less than 90 because all of them are 60. That's an acute triangle. But that's not the only way to be acute. For example, as long as they all equal 90, we could have a 50-degree angle, a um, 50, 50, and 80. That equals 180. So 50, 50, and 80, that would mean that we have an acute triangle. And in fact, because there are two 50s, which means if their two angles are the same, then two sides are the same, you would actually call that an acute isosceles triangle. And we'll talk about more of that just in the back end of this. But if we look at it by angles, then we would see that there are all the angles are less than 90 degrees, and this is one example. The second type, when we look at it by angles, is we see the right triangle. In a right triangle, we see a 90-degree angle right here, and this is called, it has one. There's one 90-degree angle in this. That's the definition of a right triangle. Now, there are some options here for those other two. If you will notice here, none of these, when we look at this is a particular length, this is a different length, and this is a third length. So in fact, this would be a right scalene, because none of the side lengths are the same, but we do have one right angle, which would mean all of the angles are actually different as well. So we can see this in a couple of different ways as well. If we were to see a right, and I'll draw it up here for you. If we were to see a right isosceles, and I'll do my best, and we'd have that right angle. We need to, my measurements may be a little off, I'm not the perfect artist, but by putting those congruent lines, I'm communicating to you that those are the same. So if I have two congruent lines, which are here and here, and then I have my right angle, what this could be is this could be a right, because that makes it a right, and then it could be an isosceles. And the reason it could be an isosceles is because of the two that are congruent. And so we see a right isosceles triangle there. So there are different variations, but the one thing this has, it has one 90-degree angle. Now, mathematically speaking, if they all three angles have to total up to be 180, you can only have one right angle. Otherwise, if you had two right angles, well, two angles themselves would equal 180, and what would the third angle be? So just be mindful mathematically, you can only have one right angle. The third way to look at a triangle would be the obtuse triangle. In an obtuse triangle, an obtuse angle, as you learned last year, is an angle that is greater than 90. Right here, this guy here is bigger than 90. And so what an obtuse has is it has an angle, just one, because again, mathematically, it cannot have more than one. It has an angle that's greater than 90 degrees. You'll see this thing really opened up on it. And then we can get into looking at the sides with the with those lengths to kind of bring that in. So the side lengths can be different, but when we look at it from an angle perspective, we're going to see just one obtuse, which that obtuse means that it is more than 90 degrees right here. So those are the three ways, and let's just kind of back away and we'll look at the overview. If we're looking at classifying them by sides, I do have my equilateral, isosceles, and scalene, and then here's some descriptions. I took this little graphic straight from a PowerPoint we did in class. That is on Converge. I urge you, check that out. This video is going to be on Converge. You're going to have that to kind of look at too. When we're looking at angles, we can have acute, which all angles are less than 90 degrees. That's what an acute angle is. So when we have an acute triangle, all of those angles are less than 90. A right triangle, only one, because mathematically, remember, we can't have more than one, but only one angle is 90 degrees. And an obtuse triangle is where one angle is greater than 90 degrees. And again, mathematically, you can only have one. So let's flip the page here and we'll stop and let's kind of dig into now some um, four-sided figures, which we call quadrilaterals. We looked at this last Wednesday and Thursday. I can classify quadrilaterals by hierarchy using words like parallelogram, trapezoid, rectangle, rhombus, and square. And in fact, we threw in another shape, which was the kite, which we'll talk about in just a second. So what is a quadrilateral? A quadrilateral is just a four-sided, closed shape that has straight lines and four angles. That's really the polygon there. The polygon itself, remember, has to have at least three sides, at least three angles. All the lines or the sides are straight, and it has to be a closed shape. So all we're doing is really fine-tuning that polygon there and saying, well, we want this one to have four sides, four angles, but it's still a closed shape with no curves. So here we go. Let's take a look at types of quadrilaterals. This is the first one. It's called a kite. The kite is really an interesting shape because it's got something that none of the other shapes have has. Number one thing is we're not going to notice no parallel lines here. And then the second thing, these two lines, if you'll notice, and I'm going to change my color here so you can kind of see visually what we're talking about here, is these are called consecutive sides that are congruent consecutive sides. And if you'll notice that my sides that are the same, this is the same, and this is the same. And then these two are the same, and how they're consecutive, one after the other. Whereas typically, when we see congruent lines, they are the opposite sides. So what makes a kite unique is a kite has two pairs of consecutive sides that are congruent. And this is important to see, and it's just really good language as you start to understand geometric reasoning. So you can talk about that. That is our kite. It kind of stands alone when we look at the hierarchy, which we'll look at in just a second. The next type is the parallelogram. A parallelogram has two sides or two pairs of parallel sides. So we can kind of see them here. Where our pairs are is this guy right here is parallel with this guy right there. And these lines are thick. There we go. And then we see here that, that's the second side. Now, again, let's think about that kite there. The kite had no sides that were parallel. That was the defining. The parallelogram has two sides. So that's kind of an important number as we kind of move on, is how many sides of parallelogram. Now, I'll get to in just a second with the hierarchy that there are multiple shapes can be classified as this parallelogram. So let's just kind of hit all the attributes, and then on the back end, I'll talk a little bit about hierarchy. Our third type of quadrilateral is the rhombus. The rhombus is a four-sided shape where all sides are equal and opposite sides are parallel and the opposite angles are equal. So what that's saying here is the first thing it says is all sides are equal. So let's first make that, we can put our congruent marks here. Much like a square, all sides are equal. Not only are all sides equal, the opposite sides are parallel. Same thing as a square. These guys are parallel. Little pink. These guys are parallel here. Now, the big difference is, and we'll get to it in just a second with the square, is it doesn't mention anything about the specific 90-degree angle. It just says that the angles are equal, meaning these two angles must be the same, and these two angles must be the same. But it doesn't really talk about 90-degree angles are a must. So just be mindful there. So that is our rhombus. Next is the rectangle. This is one of the basic primary shapes. So I know that you probably think, I'll get this one, but let me just dig in and make sure you got it. First thing is, and it hits here, every angle is 90 degrees. And you mark that with this little square that tells me this is 90 degrees. And then the opposite sides are both parallel and congruent. So this here is parallel to this side. That's when we say opposite, it's straight across. So not only are they parallel, they're also congruent. And then likewise with these tops, parallel and congruent. And I put two marks to say, hey, these two are the same and the ones are the same. So that's our rectangle. the big difference between a rectangle and a parallelogram. Now, can a rectangle be a parallelogram? Absolutely, it can be, because it's still like, we'll back over here. Does it have two pairs of parallel sides? Absolutely. It's got this one here, those two, and then it's got a second. So it's a parallelogram, but this one is a little more specialized because it has a few other attributes that say, well, you're a little different than just any parallelogram. The next one is a square. A square, much like a rectangle, will start with um, equal sides. All sides are equal. Much like a rhombus, all sides are equal. But every angle is a 90-degree angle. Now, similar, it's got opposite sides. And we see that. Parallelogram has two sets. So is a square a rectangle? Absolutely. Square is a rectangle because why? Look at the rectangle. Rectangle has a four-sided shape. Does a square have four sides? Yes, absolutely. Is every angle a right angle? Yep. And then go back here. Are the opposite sides parallel and congruent? Absolutely. So a square can be a rectangle, but not all rectangles are squares. And we'll kind of talk about that in just a second. Last one, I believe, is the trapezoid. The trapezoid's big defining mark is one side or one set of parallel sides. We just got that. And that's really it. I mean, so, kind of go back to the kite. When you think about parallel sides, the kite has none, parallelogram has two, trapezoid has one. So how does that kind of frame up? And this is called the hierarchy. Here's what I know, and I'm going to get a little color on here. A quadrilateral is any shape with four sides, four angles, straight sides. No, you got to think about the polygon. It's a polygon. So it's got to have those attributes. A polygon says at least three or more sides, three or more angles, closed shape, and no curves. Now, quadrilateral steps in and says, well, we are going to be only the four-sided, four-angle, closed, no curve shapes. Now, within the quadrilaterals, we got a bit of a family. Now, we can see that the first kind of type is this kite. The kite's defining thing, and we talked about a little bit. It's got the consecutive, congruent sides, and then it's also, you're not going to see, on most kites, you're not going to see any parallel lines, and that's kind of the defining part. The second, and I'm going to kind of work to the bigger one, so I know the order will be a little off, but the second one is that trapezoid, and then with my trapezoid, and I'm going to do this, 1 PL, and that means one parallel set of lines, and then over here I'm going to say 0 PL, just so you can kind of see how we're really sorting, we're classifying based on that. How many sets of parallel lines do you have? That's kind of that first thing when I look at it going, okay, what category do you go into? And so the trapezoid, there's just one set of parallel lines, which means our angles can be whatever. Side lengths we don't really talk about, but that's that key factor is how many sets of parallel lines. And then the third one, which is the larger of the ones we've used, is the, we've already used that color, we'll go blue, is the parallelogram. Now our parallelogram, we're going to see two sets of parallel lines. It's kind of that base figure, and that's what we talked about with the original parallelogram. We said, hey, just two sides of, or two sets of parallel lines. If you've got that, you're a parallelogram. Now, within all of the parallelograms, we've got a lot of different things going on. So particularly is that first thing we're going to look at is, well, what if you have all 90-degree angles? Well, if you have all 90-degree angles, you start to flip around into one of these two directions. You're either going to be a rectangle or a square. Well, if you have all 90-degree angles and you have two sets of parallel lines, you're going to be a rectangle. But what if all of the sides are the same? Well, then you would become a square. So then kind of work it backwards. Is a square, let's get a color, is a square a rectangle? Absolutely, a square is a rectangle. Now, does that mean all rectangles are squares? By no means, because some rectangles, although they have 90-degree angles and they have two sets of parallel sides, the only dimensional aspect of the length of sides are that opposite sides are equal. it could be longer than it is tall, so to speak. So you have to be very careful there. So all squares are rectangles, but all rectangles are not squares. But then also looking at the square, is the square then a parallelogram? Absolutely, because it has two sets of parallel lines, and easy classification there. And then you could honestly look and go, well, is a square a rhombus? Go back to the rhombus. The rhombus just said, hey, you have two sets of parallel lines and equal sides. So a square then, when you think about a square's classification, a square can be a rectangle, a rhombus, a parallelogram, and then all parallelograms are quadrilaterals. So a square is really one of the more versatile when it comes to classifying shapes. It's one of the more versatile um, of the quadrilaterals because it can be so many different things. Likewise, when you go to a rhombus can be a parallelogram because a rhombus has, within its own attributes, it also has two sets of parallel lines, and then a rhombus is also a quadrilateral. So the hierarchy allows you to look at shapes and say, well, you're different things. So don't get caught up. And I think that's going to be my key, is particularly as you prepare for this test, is look for full truths. If I were to say, what's the best description of a square, and I asked you, it has two sets of parallel sides and 90-degree angles. Was that true to be a square? Absolutely. But then in another option, you said, what has four congruent sides and 90-degree angles? Well, that's a better description of a square, because a square has to have congruent sides and 90-degree angles, whereas there's a little flexibility with the other. So be careful for those half-truths. Those will get you if you're not careful. But I've gone a lot longer than I wanted to, which is, I know you guys are used to. But I really want to dig into this. This is quadrilaterals. Take a look at this. This video is here for you. I wish I were there with you guys, but I got a lot of stuff going on. So hopefully, it's looking like I probably won't see you after spring break. So you guys take it easy. I'll be in touch. I'm going to keep doing these videos so I can stay in touch with you. And you may see me there in the mornings. But good luck on the test. Check this video out. It's on Converge. You're going to watch it today. You're going to do an activity to practice. You also have the... you got the practice test on Converge as well. So lots of tools. Good luck. Let's bring home some good grades on that thing. All right, gang. Have a good day. Do your work. Later.